In a new language, we are going to be learning the language of chemistry. Similar to how in different languages they use different sort of symbols and different notations in order to communicate. So we do a similar thing in chemistry, so we can speak the language of chemistry. By the end of this, we should be able to understand and interpret information in a chemical formula. We should recognize elements by their symbol. We should be able to know the phases of matter and indicate that with the formula. We should be able to interpret a chemical reaction and write a chemical reaction. And we should also be able to predict what we would observe if we see a chemical reaction by the equation. So those are our goals for this this lesson, a new language. Let's move on. So chemistry is communicating. That's what I'm going to start this this a lot. You don't have to write the chemistry is communicating once, but it's going to be on all sides because that's what we do. We communicate what's happening with the particles. All right. So I'll let you guys get this down. Every element is listed on the periodic table. Pretty soon, Mr. Costa and I will pass out one for you guys to keep, so you guys can take it everywhere with you. You can keep it next to your bed, and so it can be the last thing you see at night and the first thing you see in the morning. That's what you probably should do. Each element is represented by the symbol of one capital letter, or one capital letter and a lowercase letter. So, for example, nitrogen. Imagine how much of a pain it would be every time you wanted to write down nitrogen to write down the word nitrogen. So what chemists do is we just abbreviate it with the letter N. Makes so much sense. And since there's also so many elements, there's only 26 letters, it's inevitable that we have to repeat some. So what we do is we have sometimes one capital letter and one lowercase letter. For example, calcium. Calcium, we use C, uppercase C, lowercase a. So it's important to recognize that. So for every one element, we have one capital letter. So just and the capital letters are all on the periodic table. The ones we give you, the periodic tables, will also have the names of the elements on them as well. Okay? Moving forward, chemistry is communicating. And I'll give you guys a second to copy down the important things. I'll let you know. Go. So every different substance has its own unique formula. That way, as chemists, we don't get confused between substances. So the formula contains some information. The first thing that we can gather from the formula is the elements present in the substance. Okay, and that's indicated by the substance symbol, the element symbol. We can also find the number of each element that makes up the particle of that substance. So the example I use is a pretty simple one. It's K2SO4. So that can tell us that the name of this substance is potassium sulfate. So the elements that make up that are K, which is potassium, S, which is sulfur, and O, which is oxygen. Good. So that tells us the elements. It also tells us the number of each element, of each atom that makes up a particle. First element, we have K and then that 2. That 2 means there's 2 atoms of potassium for every 1 particle potassium sulfate. There's 1 atom of S. But notice something weird, that there's no 1 after that. It's an invisible 1. If there's no number as a subscript after, that means it's 1. And if you actually wanted to write K2S1O4, I'm perfectly fine with that. How about you, Mr. Costa? You can write that if you want to help keep track of it. Perfectly fine. When you get your chemistry degrees in college, you can stop that. Okay? Because I know you're all going to be chemistry majors, right? Right, Agnes? That means no. You should be nodding yes. Okay. So we can get that, and also the 4 refers to there's 4 oxygens. So just remember, if there's no subscript, we assume it's 1. All right, moving on. Here's another example. And I'll let you guys, I'll tell you guys what's important to copy down, and then we can move. Son of a gun. Looks like I have to end this. Slideshow. Moving on. So here's another example of another formula. It's a little more complicated than the first one. So here we have copper 2 nitrate, or cupric nitrate. So the name is cupric nitrate. How we write it is CuNO3 2. But notice that the NO3 is in parentheses. And this kind of is like the parentheses in math where you distribute to what's inside the parentheses. If there's 2 outside, there's 2 of all the stuff inside. Rami, can you keep your head up? Thank you. So in this case, this 2 that's in red distributes to the whole group of NO3. So in regular, just 1 NO3, there's 1 N and 3 O's. So since there's a 2 outside there, it's going to double that. So there's 2 N's and 6 O's. Does that make sense? Just like in math, just like the parentheses in math. So in the entire compound, there's 1 Cu, 2 N's, and 6 O's. Is that clear? Yes. Good? All right. Moving forward, we're almost done. In a chemical reaction, we use symbols to represent the states. Here are a couple symbols that we use to describe the normal phases of matter. And in fact, these are all the ones that we are going to use in this class. So what you want to do is, in this one, you can record the 2nd, 3rd, and 4th bullet points. So, and we'll talk about those momentarily. So, these are a few of the common symbols we use to describe the phases of matter. S is solid. That's an L right there. That's liquid. And G is gas. The other one we use is AQ, and that means aqueous solution. And that's just the fancy chemistry way of saying dissolved in water. Made a mixture with water, it's aqueous. That's it. Moving forward. So you guys don't write this down just yet, and just listen up, and we'll do more of this later. So we use symbols as a way easier way to see what happens in a chemical reaction. So this is a verbal like sentence of what would happen in a chemical reaction. Aqueous copper 2 chloride reacts with aqueous lead 2 nitrate solution, forming lead 2 chloride solid and aqueous copper 2 nitrate supernatant. Like what? Seriously. How is anybody supposed to figure out what's going on there? So what we do instead is we put together all these symbols, Henry, and we look up here, guys, eyes up here. So what we do, instead of writing this every time, imagine how much paper a chemist would need. Like, it would be horrible. Life would be terrible in chemistry. But, so since chemists, we just are such good people, we figured out ways of making life better. That's what we do. Chemists make life better for everybody. So, what we did is, rather than saying that we have this formula way. So, aqueous copper 2 chloride, CuCl2AQ. That's the symbol. To say reacts with, we use a plus. Aqueous lead 2 nitrate, listen up. We say PbNO3 2 aqueous. So that's the formula for lead 2 nitrate. Forming, we use an arrow. Copper 2 nitrate, I think I used that as an example before, aqueous. That means this is dissolved in water. And if a product is dissolved in water, we just call it, there's a name for it. It's called a supernatant. You may have heard that term in biology before. Did anybody, did you guys extract DNA in bio? I think you guys extracted DNA. You probably took a cheek cell, swiped it, and then at one point you had like a little yellow pellet in the bottom, and then you had the rest of the solution. The yellow pellet was this precipitate, and the liquid they called the supernatant. That's not too important, but you'll see some of that in chemistry. And lead 2 chloride solid. So this you can see exactly what's going on with the elements and what they're starting with, what they're ending with, what their phase of matter is, if they're in solution or if they're solid. So if you looked at this reaction, what could you tell would be mixing? You're adding two things that are aqueous. So what does that mean?
Dissolved.
Two things dissolved. So you have two solutions. You're mixing two solutions. What are we forming as a product? A solid and a solution. So what we would expect to see is we take two solutions to start with. Whoops. We're starting with two solutions here, and we're mixing them together, forming a solution and a solid. So we should see what we call a solid precipitate forming. And we'll see a lot more of this later, and in our next lab, we'll see this. So, what's our time frame? Are we running out of time? So, write this down first. We'll start with this next class, okay? So get this written down. I think we have, 2 minutes left? So, we have 3 minutes left. So, write this down. We'll start off this next class, and we'll finish this up.
Can I get the whole
Yeah, write the whole thing. And I'll give you your hole punches, and let me just stop this recording.